everybody. Today we're going to be talking about section 6.10, which is about geothermal energy. The learning objective for today is that you can describe the use of geothermal energy in power generation, and that you can describe the effects of the use of geothermal energy in power generation on the environment. So let's start with some basics of just what geothermal is and how we can use it. So if you remember back in Unit 4, we talked about how we've got like the Earth's core and it's going to be very hot, and we've got the different layers as they come up. So Earth's core gives off a lot of heat, and that's just due to natural radioactive decay of the elements that are deep in this core. Now this heat drives magma convection currents, which carry heat up to the upper portion of the mantle. If you remember in Unit 4 when we talked about some of that cycling of the magma and how it comes up and cycles back around, it's because of this heat driving it. So it's going to be moving the heat up closer to Earth's surface. Now, what we're able to do is water can be piped down into the ground, heated by this heat. We then end up getting steam, which then starts our whole electricity process that we've talked about many times this unit, where you're going to get steam, which is going to spin a turbine, which is then used to make a generator, make electricity, and then the electricity is able to be used. So once again, it's still that water is getting heated into steam. We are just using the heat from Earth's core to do it for this type. Now, this kind of shows you a diagram right here. So if we're going to have down here is going to be Earth's core with like the hot magma. What we naturally have is we actually have these like reservoirs right here, which are natural reservoirs of water deep in the ocean. And so when you're getting the heat, this is going to create steam. Now we are able to go and pipe down, get pipes to bring that steam up. And then once again, we spin a turbine, which then the generator, which then it's going to go to electricity there. You can even use it to be like directly heating homes, which we'll talk about in a bit. But this is kind of using the geothermal for electricity production that can be used throughout all businesses and places connected to the power grid. So again, we're going to have this steam going up. It's going to be spinning the turbine, which is going to result in the production of electricity. Now, what we also have is a cooling tower. So after the steam has spun the turbine, we will recollect the water vapor. We are going to put it to this cooling tower. It's going to condense. It's going to come down. And then we're able to pipe it back down to the reservoir to be used again, so we can keep that cycle going. And this is what makes it renewable. Now, Earth's core heat is not going to run out. I mean, it will eventually in like millions of years, but we have a much bigger problem besides electricity at that point. We will not be able to survive on Earth. So for the foreseeable multi-million year period where we are going to be around, we are going to be having this be a renewable source of heat. And then what makes this truly renewable is if we have this cycle set up where we keep using or replacing that reservoir water and back steam to cool to water to steam to cool to water. That is going to keep it renewable. If we were just going in and using up all the steam and draining it dry and moving on, then it would not be renewable. But if we've got this whole system set up, it continues to be renewable because we're going to be able to keep going with it. So that is for making electricity. Now this is going to be geothermal for actually warming homes and businesses. So again, we're going to be piping down deep into the ground. That water is going to be heated by the magma. And then we are able to have warm water pumped back up for the steam. And we actually use that heat to heat a building or individual homes. Now, one of the difficult things is that the well needs to go down thousands of meters, so like multiple kilometers down into the ground to actually reach these heated water reservoirs. So it's not just right at the surface. This is not going to be something that someone's just setting up in their backyard. You have to have a whole system that you're connecting like quite a few different places to make it worth it. So for example, if you see right here, you're going to have this coming down, you're going to have the heat coming up, and then you might have a whole system set up to where you're going to have the heat able to be transferred. And that hot water, is going to be what can be used to warm, because the hot water will give off So if you've ever used like a radiator heater where you get the hot water into pipes and that heat is what releases, you would be able to have this on kind of like a whole scale system to transfer that so that you are able to have the heat warming homes. Now, typically, we are more commonly going to be talking about geothermal for electricity production. It oftentimes is not really worth all of the effort to just heat a few homes, but theoretically, it is a possibility. So here's going to be some of the pros and the cons of this system. Now, again, it is ideally renewable, but only if the water is piped back into the ground for reuse. If you are piping the water back down in for reuse, then it is a renewable resource. We also are going to have much less carbon dioxide emissions from fossil fuel, or much less carbon dioxide emissions than what we have with fossil fuel electricity, which decreasing our greenhouse gases is always a good thing. Additionally, you don't have any release of like the particulate matter, the SOx, the NOx, carbon monoxide, as we do have release with fossil fuels. Now, some of the cons is that not everywhere on Earth has access to geothermal energy, reaching close enough to the surface where we could access it. If you look at this map here of the United States, everywhere that has like red or purple, that's going to be close enough where we actually are probably going to have it be a possibility if we wanted to. Anywhere where it's like yellow or green, it's going to be so far away that we would not even be able to realistically reach those reservoirs to use it. Another thing that is a problem is that sometimes in this process, hydrogen sulfide gas can be released, which is toxic and can be actually lethal to humans and animals. So if you are releasing that in the process, that's clearly going to be no good for the living organisms above. Now, the biggest con of geothermal is that it's very expensive. Like you're drilling kilometers into the ground. And so a lot of times places don't really feel like that initial cost is worth it. However, if you are talking about an upfront cost that then eventually can be used for reusable energy, it's not something that goes on and off during the day. You're always going to have a hot core. So maybe, especially when we're starting to run low on some other options, maybe there are communities that do feel like this is a viable option and it's worth the money because even though it's an upfront cost, it'll be worth it for many years to come. But sometimes, especially in these areas where it's farther away, the upfront cost is just not worth it. Some places, you could argue that over time it would be worth it. So here's going to be your practice FRQ for 6.10. I want you to identify the source of initial energy in geothermal power generation and explain how geothermal systems can be used to generate electricity. That's going to be your practice FRQ for 6.10. And those were your notes on 6.10 about geothermal power.